Hello together, my name is Mark John and I'm coming from the Frauen Institute of Technology Trend Analysis. It's located in the beautiful city of Euskirchen, which is probably not so known so well, but it's near Cologne and near Bonn. And I'm presenting here some results concerning bibliometrics and the application of bibliometric methods to technology forecasting and technology foresight and technology assessment. It's an ongoing research project we have at our institute where I'm collaborating mainly with my co-author Frank Fritscher, who is mainly responsible for all the programs we've written to do all these bibliometrics and so on. And okay, let me first start with a simple but important statement about an assumption about technology and what we are doing, mainly that tomorrow's technology is based on today's work in the scientific laboratories. This means in order to assess and to detect what's going on or what technologies might be important in tomorrow in the future, we have to go into the scientific laboratories and to look what's going on there. But of course that we can't do, but we have the publications, and that's why we need a kind of science observatory in order to do technology foresight. We have to scan the whole scientific landscape and look for new stars rising up in the sky of science and to assess them, how important they might be for future developments. And this is what we do at our institute. We have a kind of science observatory. Each of our colleagues is responsible for a certain part of the scientific sky, scanning it. And we are currently investigating whether this process, this science observatory, can be helped by means of bibliometric methods, because bibliometrics is standard definition would be the statistical analysis of scientific publications, but I like more this more pictorial definition that bibliometrics is quantitatively eavesdropping on scientific communication. That is, we listening to what science say by publishing their papers, and we are doing this quantitatively. And I mean, this is one certain aspect which has certain advantages of bibliometrics. But we have to remember, bibliometrics is an inherently retrospective method. With this we mean that all the publications we analyze by bibliometric means are already published. If you take also into account that we are looking at citations, it still takes longer. Thus, if we have a bibliometric, so to say, signal, the time has gone in the laboratories, and we have a time gap of about, let me say, 1 or 2 years until we have a really signal. The work in the laboratories might be still further. This you have to keep in mind that when you're talking about bibliometrics, and this is what we mean when we call it a retrospective approach. Okay, if you're doing technology foresight, you have 4 different phases. The first phase is to identify a scientific theme, a technological topic, by scanning the scientific skies, by doing a scientific observatory. Then you have to analyze it. You have to give a definition of the topic. You have to give a description of what is this technology about it. And then you have to assess it. You have to say how important it is for you, for the society, for your customer, who else. And finally, you have to communicate your results. It's an important point because until here you are working at your desktop or in your cubicle, but here you have to go to the customers, to the society, and you have to communicate all your results. So when you're doing technology foresight, you all will probably have the know that you don't have experience, that you don't have too less information today, but we have too much information. I show you here the number of publications given in certain scientific databases. This green line is the Web of Science, is the Scopus. This red line is a famous Web of Science. This yellow line is the Medline, and this blue line is the InSpec database. And as you see, we are currently getting more than 1 million papers per year in these most important databases. So we can say we don't have a information deficiency, but we have an information flood we have to handle. Okay, in order to do bibliometrics for technology foresight, we developed a method we coined trend archaeology. And what's the idea behind this? Well, we first took historic scientific trends. I'll give you some examples later on, and have done a synoptic, multi-dimensional bibliometric analysis. With this, we mean the following. Synoptic means that we took these historic trends and simultaneously looked at them and analyzed them and put them all, so to say, the plots on the table and analyzed them. The multi-dimensional means that we did considered many bibliometric observables. We not only considered the publication dynamics, but we simultaneously considered the publication activity of actors, the document types, the cooperation, and the co-author networks. And we continuously extend this list of observables. And finally, we have this method, which we call trend archaeology, and we try to look for pattern in the development of historic trends. We are trying to look for regularities, turning points, etc. And we are considering whether we can establish a kind of classification scheme for those emerging topics or these historic trends. In order to do so, we have established a quite elaborate bibliometric workflow. It all starts with a search query where we try to delineate the scientific topic. 5 minutes? Okay. Search queries, and we try to delineate the field as exactly as possible, and this is an iterative process. If you have such a search query, we get the data from the databases, and then we have to process the data. We have to structure them so that the computer can count them. We have to correct for errors and such things. And finally, we have the clean data, and we can then real analysis, we can do visualizations. In all phases, we need, of course, an expert, because all these phases are not done automatically. At every step, we need somebody to look at the data, at the results, and to say, well, that's correct, or well, you have to do something over here. These are the themes we have currently under investigation. We have 9 themes from nanotechnology, fluorine and nanotubes, graphene. We have 3 themes more or less from the solid state physics, bimetallic glasses, high temperature superconductors, and the pathological example called fusion. And we have 3 examples from the cyborg sciences, human enhancement, transcranial electrical stimulation, and the cochlear implant. I skip this because for time reasons. Just let me note that we have 3 themes which already gained a Nobel Prize. And then we have already the most simple but already quite instructive pattern, namely the publication dynamics. And here you see already 3 types of pattern, namely this pattern, which is a growth type pattern, which are called 1A and 1B, because this is only a special case in a mathematical sense of this case. And we have also this, which we call the curve of disappointment. We observe further patterns for communication channels and co-author networks. We might show them in the discussion. And to jump already to the lessons we get from trend archaeology for technology foresight, with all this process means a kind of complexity reduction, and we can show that it works. We already can identify different patterns for publication dynamic, the densification of the co-author network, and the communication channels. And I personally already think this is right astonishing, because the temporal evolution of scientific themes seems to follow different patterns. I mean, science is such a complex system, and we can observe quite simple patterns, which also seem to be a picture of the underlying processes in science. And I find this quite astonishing, and I think this is a point where one should go into greater details in the future. The outlook would be to establish a classification themes, to try to quantify these patterns, and to take more themes into account. We now had already, in the first phase of the technology foresight process, and now we have to try to analyze the theme, and now we try, I will discuss with you the art of a search query. I will, here in this plot, I show you the complexity, so to say, of a search query. We have here the number of terms. This is the number of search terms in a search query, and we have the number of unique terms. This is those which are only, it's a little bit difficult to explain without the general structure. Okay, they are unique in this sense that they are they are unique terms in a search query. And you see here, for example, for graphene and high temperature superconductors, there are only or almost only unique terms. This it's quite simple to delineate these fields. You see also that fields like code fusion or the transcranial electrical stimulation has many search terms here, this one, but many of them are not unique because because of this abbreviation. This means that you have to take into account that this abbreviation could also mean something completely different than transcranial electrical stimulation. And so we see here that we have an increasing complexity. It's getting more complicated, this search query, and we have also an increasing fuzziness in this direction. What we can also do is span on the conceptual space of a theme. This is done here for the field of computational material science as an example, where we analyze the keywords and the co-occurrences, and you also get a rough overview over the complete field of computational material science. This is quite useful if you start to work on a quite complex theme. So we have some lessons concerning bibliometrics and information retrieval. So lesson 2, the first lesson is that the search query reflects the conceptual history underlying a scientific theme. The second lesson is that bibliometric might support the process information retrieval. Who's ever done a search in the Web of Science, for example, looking for highly cited papers, is already doing some bibliometrics in information retrieval, but this can be done in a more complex way. Keyword analysis helps revealing the conceptual structure of the theme, and the problem still is that we need a better integration of bibliometric tools into the internet. Okay, now I'm finished? Okay, we have already done some research on visualization of the structure. The bibliometric results here, you have a counter example because you can't also see almost nothing. And here we try to densify the results. This is radar plots where you have for the scientific theme the rank of a country plotted. And you see here, for example, that in some cases China, which is located here, plays a dominant role, and in other cases it's not so dominant. And also here, the message here is to have a pattern which you can clearly see if you see with the radar plots. Important is also the analysis of cooperation in scientific themes, and here you see a classic visualization using a world map. Okay, you see something, okay, USA, but we are currently investigating whether these chord diagrams are perhaps more useful, more compact and denser kind of visualization which gives more insight into this structure of the cooperation network. So let me state this for visualization. Visualization, of course, is crucial for revealing patterns. Visualization is useful for communicating the results because all our customers like these pictures, so to say. And we are currently trying to improve our visualization techniques. And let me summarize it as in the whole process. The phases of technology foresight, bibliometrics might be useful in identifying new scientific topics. I say might be because bibliometrics is a retrospective method. Obviously, bibliometrics is useful in analyzing, assessing, and communicating the results of a technology foresight and assessment process. Okay, and with this, I'm finished. Thank you.
Thank you very much, Markus. We didn't quite do it on time, so there's not much time to discuss, but probably you have plenty of questions.
Since you're interested in this foresight aspect, and you pointed out the gap of the 1 or 2 years that you have when you look at bibliometrics, I wondered if you also are interested in a more current metric, which would be alt metrics, so alternative metrics, which consider, for example, social media and activities like that. Is that something that you look at or that you potentially would be interested in?
Yes, I know that there's an ongoing discussion in the scientometric community about Altimetrics, and to be honest, my personal view is that this is not what we are looking for, because it's quite, Altimetrics is mainly focused on the, no, let me state it the other way around. My experiences when I do technology analysis is that everything, everyone is hyping a theme. When we go into the greater details of the technology, and then it's like a balloon which is inflating because there's nothing mentioned. That's in most cases is a certain nucleus, an important nucleus remaining, but it's not this hype aspect is getting lost, so to say. And that's why I'm personally doubtful whether Altimetrics might be useful for technology, for our work in technology foresight and assessment.
Well, I share your doubts, and so again, I'm sure that analysis, assessment, communication is fine, but the first phase, I doubt if there has ever been one example or an example where you could identify with these methods a topic that was not in the air or that other methods had detected going to whatever might be competing with this method. So once you have a hypothesis that there is a new theme, from this point on, it will be useful, you can imagine. But
no, that's why I'm saying bibliometrics might be useful in identifying. I personally completely agree with you, and I doubt it also. And
if there was at least one example.
We had a project where we combine a project at our institute where our working group compared the results of a technology foresight process with other institutions which all which used different methods. And one of these other methods was bibliometrics. And they failed. They didn't perform as good as we who did simple desk research. So that's why I say bibliometrics can help us identify. It's if I may switch to German for a short moment, Bibliometrie hilft uns, Ahnung zu quantifizieren. Bibliometrics helps us to quantify a guess. Yes, thank you. So we have a guess about what's new in technology, and bibliometrics might help us.
Does bibliometrics help us understand past trends? I remember the first slide with all the different scientific developments show different curves.
Yeah.
Can we understand why those curves behave in that way like in bibliometrics?
Can we understand what?
Why the publications curves go present that shape from bibliometrics?
Yes.
So the very first slide where we presented the different scientific topics that you have addressed.
Okay. Of course, this is difficult for themes which are still in their growth phase, but here for the high temperature superconductors, of course, there you can say that we, from scientific point of view, we currently do not know the reason why certain materials are superconducting at high temperatures. And until this is reached, until we do not, as long as we don't know why certain materials are superconducting, I guess this curve will declining or at least getting here into saturation. But as long as we don't have this breakthrough, you don't have this. And for example, here you have a growth phase, then you have the phase of stagnation. This is also due to the because of certain aspects regarding the production of bulk metallic glasses. And then you had at this point, again, in this area, a breakthrough, and then you have also, again, a growth in the publication phases, and until now, currently, there's again a phase of stagnation. This is an important question where you have to go into the details. You have to look what's happening in science around these turning points in order to understand what's the scientific problem, what's the breakthrough, etc. pp.